So in this problem, we need to determine the equation of a parabola such that its focus is at the point 0, -3 and the vertex is at the origin. So let's try to understand it graphically first. We are going to consider a straight line. And on the straight line, we're going to consider 2 points. Let one point represent the vertex of the parabola, which is at 0, 0. And we have another point to the left of the vertex. Let's consider that point to be the focus of the parabola, which is at 0, -3. So this is given to us. Using this, we need to find out the equation of a parabola. Now, what we'll do, in order to find out the equation of a parabola, there are two information that we need. One is the coordinates of the focus, that's already given to us, and the other information that we need is the equation of the directrix. Now, let's say, to find out the equation of the directrix, we'll begin by considering a point A which lies on the same line. Now, by definition, this line is named as the axis of symmetry of the parabola. So, axis of symmetry is the line on which the vertex and the focus lie. Now, the point A, we are going to choose the point A, let's say it has the coordinates A, B. We're going to choose point A in such a way such that its distance from the vertex is exactly equals to the distance of the vertex from the focus. Now, what we'll do, we'll pass a straight line which is going to be perpendicular to the axis of the parabola and passing through the point A, B. So this is going to be the directrix line. So what we'll do, we'll try to find out the equation of the directrix line, and we know from the properties of straight line, we can find out the equation of a straight line if we are given a point which lies on the line and we also are given the slope of the line. Now, we don't know the slope of this line. However, we can use the fact that two perpendicular lines have the product of their slopes equals to -1. That means if we can find out the slope of the axis of symmetry, then we can easily find out the slope of the directrix line. So let us begin by first trying to figure out what the slope of the axis of symmetry line will be. So we will suppose that the slope of the axis of symmetry be m1. Then we can easily find out the slope of the line because we have 2 points, the coordinate of the vertex and the coordinate of the focus. All we have to do is take a ratio. In the numerator, we will consider the difference of the y coordinates. So we'll start with the y coordinate of the vertex and from it subtract the y coordinate of the focus. So that's -3. And in the denominator, we'll start with the x coordinate of the vertex and from it subtract the x coordinate of the vertex. So this will be equals to 3 over 0. Now here we have as division by 0, which means that the slope of the axis of symmetry line is undefined. Now, since the slope of the axis of symmetry line is undefined, it simply means that the line is actually parallel to the y-axis, or we can say it is perpendicular to the x-axis, which automatically tells us that this is the line which is going to be parallel to the x-axis. Our directrix is parallel to the x-axis, so that means its slope is going to be equals to 0. Now let's suppose that the slope of directrix is given by m2, and what is the slope of the x-axis? That's simply equals to 0. So that means the slope of the directrix line will be equals to 0. Now we have the slope of the directrix lines. We need to find out the point A, and that means the coordinates of point A. Now, by definition, we have already mentioned that V is the midpoint of the line segment joining point A and point F. So that means what we can do, we can take the sum of the x coordinates of point A and point F. So that will be A added to 0, and we're going to divide it by 2. And we're going to do the same thing with the y coordinate. We're going to take the sum of the y coordinates of point A and point F. That means we have B added to -3 divided by 2, and this is going to be equals to the coordinate of the vertex, which is 0, 0. Now, when we equate them, this is going to give us the value of A as 0, and the value of B will be equals to 3. So that means that the coordinates of point A is going to be, this implies that coordinates of point A is going to be 0, 3. So now we have the point through which the directrix line passes, and we also have the slope of the directrix. We can easily find out the equation of the directrix. That can be obtained by using the point slope form of a line. So using the point slope form, the equation of the directrix is going to be y minus y1. That means we have to take the y coordinate of point A, so that's 3, equals to the slope of the directrix, which is 0, multiplied to x minus the x coordinate of point A, so that's 0 as well. This is going to give us y minus 3 equals to 0. That's the equation of the directrix line. So we now have the equation of the directrix line, we have the coordinates of the focus, we can find out the equation of the parabola. That means let's try to understand the problem graphically again. So we have the directrix line with the equation y minus 3 equals to 0. And then we have the axis of symmetry line on which the focus point line, the focus was given at 0, -3. Okay, we have 0, -3, that's the coordinate of the focus. We have to find out the equation of the parabola. To begin with, we are going to consider a point P on the plane such that it has the coordinates h, k, and the position of P is very important. It's chosen in such a way so that if we join point P and point F and we drop a perpendicular from P on the directrix line such that it meets it at M, then these two distances PF will be equals to PM, which is going to give us the equation of the parabola. So by definition, we have PF equals to PM. Now we can easily find out the length PF because we have the coordinates of the endpoint. Here we can use the distance formula. We'll take the square root. Underneath the square root, we take the difference of the x coordinate. So we do h minus 0, square this value, and then add it to the difference of the y coordinate. So that's k minus 3. So we get k plus 3. We're going to square this value as well. This will be equals to PM. So PM is the perpendicular distance. So here we're going to use the formula for finding out the perpendicular distance of a point from a straight line. So we'll take the absolute value. Inside the absolute value, we have to take a ratio. So here, what we'll do, we're going to rewrite this equation of the directrix. We can rewrite it as 0 times x added to 1 multiplied to y minus, or it can say positive times -3 equals to 0. All we are doing is expressing it in the general form of a line, which is ax plus by plus c equals to 0. So we'll start with the coefficient of ax of the directrix line, so that's 0. 0 gets multiplied to the x coordinate of point P, so that's h. That will be added to coefficient of y, which is 1. 1 gets multiplied to the y coordinate of point P, so that's k. And that will get added to the constant term c, which is -3 in our case, divided by the square root of, so we have to take a squared plus b squared, sum of the squares. So we'll take 0 squared and add it to 1 squared. Let's further simplify. This is going to give us the square root of h squared plus, we have k squared plus 6k plus 9. That will be equals to the absolute value of k minus 3 divided by 1. We're going to square both sides to get h squared plus k squared plus 6k plus 9 equals to k minus 3 whole square. So expanding k minus 3, we get k squared minus 6k plus 9. And on the right hand side, well, left hand side, we have h squared plus k squared plus 6k plus 9. So here, k squared and 9 will get cancelled out from both sides, which leaves us with h squared equals to, so we're going to transpose this 6k to the right hand side to get -12k. And finally, we're going to replace the value of h with x and the value of k with y, which gives us the equation x squared equals to -12y. And this is going to be the required equation of the parabola.